Simplifying maths. Today we're going to go through surds in National 5 maths. We'll look at simplifying surds and rationalising the denominator. But before we get there, let's do some teaching. What is a surd? Okay, so what is a surd? A surd is any number that can be written as a root, but you cannot actually work out the root. So for instance, root 2, if you were to place that in a calculator, it would go on forever. It's called an irrational number. Whereas root 4 would be 2. So root 2, root 7, and so on. But we can simplify surds if they're bigger into smaller chunks just by finding a square number that goes into the number. So let's have a look at some simplifying surds examples in a very basic way. So let's take a look at the square root of 12, for instance. Well, to simplify a surd, I just need to find a square number that goes into 12, and I can times two numbers together to do that. 4 times 3 is 12, so I can write the square root of 4 times the square root of 3 is the square root of 12, and therefore the square root of 4 is 2, so I get 2 root 3. So you need to know your square numbers, okay? Let's take a look at a harder example, the square root of 75. Well, 25 is a square number, so 25 times 3, so I get 5 root 3 because the square root of 25 is 5. Let's look at a one which does not have a 3 in the answer. Let's look at the square root of 50. Again, that's 25 times 2, well that is 5 root 2 because the square root of 25 is 5, but I can't square root the 2. And you could have numbers that are much bigger than this or much small, well not much smaller, but much bigger than this. So we could have the square root of something like 300. That would be the square root of 100 times the square root of 3. Square root of 100 is 10, so we get 10 root 3. Just remember when you're simplifying surds, you're looking for the biggest square number that goes in. Sometimes more than one will go in, so you need to try and find the biggest. If you can simplify more than once. Let's look at some more complicated examples with simplifying surds. Let's say we had a number in front. So let's say we had 2 root 27 and we were trying to simplify that. Well, the 2 just hangs around to the end. So that we would just say we've got 2 times square root times square root. Well, for 2 numbers at times together to make 27. 9 and 3 would do the trick because 9 is a square number. And then I can just square root the 9 to get 2 times 3 times root 3. And anything outside of a root can be times together, just like anything inside of a root can be times together. So that's 2 times 3 is 6 root 3. Let's look at another example like that. Let's say we're doing 4 root 8. Again, that would just be 4 times 2 square roots. 2 numbers at times together to make 8. One's a square number. Well, that's 4 and 2. I always like the square number first because I know I'm going to square root that 1. So square root of 4 is 2, so that gives me 4 times 2 times the square root of 2, which gives me a final answer of 8 root 2 because 4 times 2 is 8. Now we can move on to adding surds together. The basic idea with adding surds is as long as the root's the same, you can add them together like algebra. If you've got like x plus x, you've got 2x. If you've got a banana plus a banana, you've got 2 bananas. If you've got root 2 plus another root 2, you've got 2 root 2s. So here's a simple example. If I had 5 root 7 plus an extra root 7 minus 3 root 7, I'm just thinking that it's 5 lots of something plus 1 lot of something minus 3 lots of something. 5 plus 1 is 6. 6 minus 3 is 3. So I've got 3 root 7. Let's do another one like that. Let's say I had 14 root 3 plus 6 root 3 minus root 3 plus, let's say, 5. So now what we've got is some different things. We've got some root 3s, but then a 5 hanging around on the end. You cannot add different things to surds. You can't do 5 plus a root 3 and get an answer. So we'll just do the root 3 things together and then leave plus 5 on the end. So I've got 14 plus an extra 6 is 20, minus 1 is 19. So that gives me 19 root 3, and then I've still got plus 5 on the end that I can't do anything with. So we end up with a mixed answer. Let's look at sometimes when the surds are different, but somehow you can simplify. So quite often you will get something like simplify 2 root 6 plus root 24. And it looks like you can't do it because these are different, so they don't add together. But if you notice, this number's quite big, so you might be able to simplify that. And if you can simplify it and make it look like this one, then you'll be able to add them together. So at the side, I'm going to simplify the root 24. So root 24 is equal to square root times square root, remember. Two numbers at times together make 24. One's a square number. Well, that's 4 and 6. So that gives me 2 root 6. Oh, look, root 6. So now I can rewrite my question as 2 root 6 plus, and then I've just got another 2 root 6 for the root 24. So that gives me 2 plus 2 is 4, lots of root 6. And that's a very simple example of adding. Let's look at a more complicated example like that. Let's say we wanted to simplify 4 root 27 minus 3 root 3 and then plus 2 root 48. So now we've got a lot of mixed different ones. So my smallest one can't be simplified because that obviously there's no square numbers that go into 3. So I'm going to try and simplify this one and this one and see how far I go. So looking at the root 27 part, that is square root times square root, 9 and 3. That makes 3 root 3. And then we can move on to our root 48. 48, well, that's a square root times a square root. 16 times 3 is 48. Now, if you picked 4 here, that's too small. You'd have to do it again. So 16 times 3 will give you the answer of 4 root 3. And now we can change our sum into these ones. So if we start off with the 4 root 27, that became 4 times 3 root 3, because we've got 4 in front, remember. And then we've got minus 3 root 3 still there. And then we've got plus 2 times root 48, which is 4 root 3. So now we need to simplify that. I'm just going to use one colour for it all now. Well, 4 times 3 is 12, so I can times things outside. 12 root 3 minus 3 root 3 plus 2 fours is 8, 8 root 3, and now it's a nice simple one. 12 take away 3 is 9, 9 plus 8 is 17, so we get 17 root 3 as our final answer. Notice if you do end up getting two different roots, you'll just end up with an answer which is a mixed surd answer. Look at some simplifying when you get times and surds together. So let's say we had a question like root 13, this is a simple one, times root 13. Well, it doesn't look like I can do much, but I can put any roots can become one root, and it's just 13 times 13. As long as they're both under a root to begin with. Well, 13 times 13 is 169, and the square root of 169 is 13. Notice with a specific example, if it's the square root of a number times the square root of the same number, then that just cancels the root out to get back to 13. Let's look at one that doesn't quite do that. Let's say we had root 8 times root 12. Then you can either simplify the surds first or at the end. I prefer to simplify first. So root 8 is root 4 times root 2. And root 12 is root 4 times root 3. So now I can square root whatever ones I can square root. Square root of 4 is 2, so that's 2 root 2, times the square root of 4 is 2, so that's 2 root 3. And then you just need to remember that things outside can be times together and things inside can be times together. So the 2 times 2 gives me 4 outside, square root. The 2 times 3 gives me 6. Just check that there's no square numbers that go into 6, and there isn't, so you're done. Alternatively, if you prefer, you could do 8 times 12, which is 96, and then simplify the square root of 96, which would be 4 root 6 as well. So now we move on to rationalising the denominator. What does that mean? Well, let's look at an example first of all. If it's told us to rationalise the denominator of a simple example like that, 2 over root 3, well, the denominator is a fraction, and the denominator is a square root. We've already learned that a square root of a number is called a surd, but it's also irrational. So to make it rational, it just means to make this a whole number or a fraction. And how do we do that? Well, there's a specific technique we can use, and simply all you need to do is times by the denominator over itself. Now, why does that work? Well, that's because you're timesing by 1. Anything over itself is 1. So by timesing by a special 1, I'm not really changing anything. So I times just the top, 2 root 3, And if you just remember from our previous examples, the square root of a number times the square root of the same number is just the number. So it's 2 root 3 over 3. Now, here's a common mistake that people make. Do not make this mistake. You cannot do root 3 divided by 3. Although you'll be tempted to think that's something to do with 1, it's the square root of 3, and that's just 3, so they can't be done together. So only 2/3 root 3. So we're done. If you could simplify this outside fraction, you would do that, but that's the only thing you could do in this example. Let's look at a harder example. So let's say we had 6 over root 50. Now there's 2 ways to go with this one. You either simplify the root 50 first or last. I'm going to do it last. So I'm going to times by root 50 over root 50, because that's the denominator. That gives me 6 root 50 on the top and just 50 on the bottom. So now we've got a bit of work to do with this question, because we've got a 6 and a 50, which is a fraction which can be simplified, and we've got a root 50, which is a surd, which can be simplified. So we'll do a lot of this work at the side. If I take my root 50 to start with, well, that is root 25 times root 2. So that is 5 root 2. That means that we can say that up here our answer becomes 6 times 5 root 2, and it's still over 50. So what does that equal? Well, that's 6 5s is 30, so that's 30 root 2 over 50. And now we've got this big fraction outside that we can simplify. The 30 and the 50 can be simplified to 3/5 by dividing by 10. So taking a little note of that, we're dividing the top by 10 and dividing the bottom by 10 to get 3 root 2 over 5. And we're done there. Slightly more complicated example, this time with a root on the top and the bottom. So let's say I had root 3 over root 6. Do not be worried about these ones. You just times by the denominator over itself. So not root 3 over root 3, root 6 over root 6. And then remember, when you're timesing 2 roots together, you can just make them one root. So that is the root square root of 18 on the top, 3 times 6. And the square root of 6 times the square root of 6, since it's the same number, just becomes 6. But now I've got root 18. Well, I wonder if I can simplify that. 2 square roots, and that's still over 6. And that's 9 times 2 makes 18. Square root of 9 is 3. So I get 3 root 2 over 6. But 3 and 6 can be simplified as a normal fraction by dividing the top by 3 and then dividing the bottom by 3. 3 divided by 3 is 1, so we get 1 root 2 over 6 divided by 3 is 2, or just root 2 over 2. Do not go any further than that. You can't do the 2 divided by 2 part because it's a root over a number and that's not allowed. Only roots go together or numbers go together. Don't mix them up, okay? Let's look at one further example, a little bit more complicated. 3 root 12 over 2 root 60. Now, remember we said earlier we can simplify any numbers that go together or any roots that go together. So we can simplify these by dividing inside the root. So that becomes, if I divide that by 2, saying that by 2, that's okay because they're both under the root. So that would give me 3 root 6 over 2 root 30. I could divide by 2 again inside. As long as you're staying inside or staying outside, you're okay. So that gives me 3 root 3 over 2 root 15. Oh, I can do it again. 3 goes into both of them. So that gives me 3 times the square root of 1 over 2 times the square root of 5. So that gives me a final question of 3 times the square root of 1 is 1 over 2 root 5. I've simplified it right down to this. Now you could have got there quicker because 12 goes into 65 times. So you could divide it by 12 to start with to get 1, divided by 12 to get 5. And now the question becomes quite easy. You can just times by root 5 over root 5. And that gives you 3 root 5 on the top and 2 times, well, root 5 times root 5 is just 5. So that's 3 root 5 over 10. And we're done there. Let's go on and look at all the past paper questions in National 5 Maths on Surds, and hopefully you'll get a good hang of this. Start past paper question 2014, paper 1, question 8. Root 40 plus 4 root 10 plus root 90 as a surd in its simplest form. Can't add them until we're all simplified. So let's start with root 40. So we've got root 40, well that's just 4 times 10 to root 10. Notice our root 10 has appeared, and we now know that root 10 is already simplified because 4 is the biggest square number that goes into 40, and it gave us root 10 as an answer. So I don't have to try and simplify my root 10. So I'll now go and simplify my root 90. Well, that's 9 times 10. Square root of 9 is 3, so that gives us 3 root 10. So our whole sum simplifies into 2 root 10 plus our 4 root 10 that was already there, plus an extra 3 root 10. So adding all them together, 2 plus 4 is 6, plus another 3 is 9. Our answer is 9 lots of root 10. And now I mean a standard deviation question, this time in the SQA National 5 Maths 2017 paper 1, question 12. So again, a non-calculator one. Gym members are asked to fill in a questionnaire to rate the quality of the service provided. They'll ask to rate on a scale of 1 to 6 as shown. 5 gym members picked 1, 4, 6, 3, 6. And its simplest form of standard deviation can be written as A root B over 2. Calculate the values of A and B. Do not be worried that we've done that. That means that we're just combining this with surds. But your step, it's mentioned standard deviation. So again, you're going to calculate standard deviation. So step 1 is to draw my table, but I get the formula from the start of the exam paper first. The sum of x minus x bar squared over n minus 1. That's a little bit messy. But our table, if you recall, is always the same. X minus x bar, and x minus x bar again, squared, all from the top. And we can write down our numbers, 1, 4, 6, 3, 6. 1, 4, 6, 3, and 6. We add them up at the bottom. So being very careful, 6, 7, 8, 9, 15, 19, 20. So our total is 20, which means our mean is 20 divided by 5, which is 4. In the middle, we take away our mean then. So 1 minus 4 minus 3, 4 minus 4 is 0, 6 minus 4 is 2, 3 minus 4 is minus 1, 6 minus 4 is 2 again. And then the last column was square. So that gives me 3 3s is 9, 0 0s is 0, 2 2s is 4, 1 1s is 1, 2 2s is 4. And then we add them all up. 9, 13, 14, 18. There's our key number there. Already we've got a mark for calculating the mean, a mark for getting x minus x bar, and then we get another mark for substituting that into our standard deviation, which is the square root of 18 over 4. One more mark left just for using surds. So we have to leave it in the form A root B over 2. So we need to simplify this in some way. So we can separate that into 2 square roots, square root of 18 over the square root of 4. I need 2 numbers at times together to make 18, one of them a square number, so that's 9 times 2, and the square root of 4 is 2, so that leaves a final answer. Square root of 9 is 3, root 2 I can't do anything with, all over 2, our final mark, 3 root 2 over 2. Refer back to my surds in the numeracy unit to get more work on surds. Okay, completing the square and the quadratic formula. SQA National 5 Maths 2018, paper 1, question 19. Quite a big one this. Part A, express x squared minus 6x minus 18 in the form x minus p squared plus q minus p squared plus q, or minus a squared plus b, completing the square. Then state the axis of symmetry, which we'll get to, and the roots of this can be expressed in this form. Find algebraic of D and E. So this is a quadratic formula question in a paper 1. We've expressly put it like that because that's what it looks like at the end or before you've got your answer. So let's go through this step by step. Question A. I've got x squared minus 6x minus 81. So to complete the square, I go like 1 bracket squared, x minus half the middle term is 3. Now, how do I get my numbers on the end? Well, I immediately take off that number squared. So the number is take away 3 squared, technically minus 3 squared. Then you're going to still take away 81 because that's hanging around on the end. So that gives me x minus 3 squared. 3 3s are 9, so it's take away 9, take away 81. Because I'm over by 9 basically. So that gives me x minus 3 squared minus 9 minus 81, that's minus 90. And we're done there. Part B, 10 state the equation of the axis of symmetry. When you complete the square, we don't do it for nothing. It tells us something. It tells us the turning point. The turning point is this number here and this number here. That sign changes. So if it's minus, it becomes positive. Positive becomes minus because you're making this bracket 0. So my turning point is 3 minus 90. I'll just write that down. My turning point, which we may ask you in some questions, is 3 minus 90. When you draw a quadratic, it is symmetrical at the turning point. So when they ask you for the axis of symmetry, we're just asking you for x equals 3 because it's a vertical line, so x equals the number. Where does this 3 come from? The turning point. So that's all we're asking you there. Part B says, the roots of the equation x squared minus 6x minus 81 equals 0 can be expressed in the form x equals d plus or minus d root e. Find the values of d and e. There's two ways to actually do this. You can start from completed square form, or you can go back and use the quadratic formula. I think most people will use the quadratic formula rather than the completed square form, so I'm going to do it that way. But just be aware you can do it that way. So let's start off with x squared minus 6x minus 81 equals 0. If we look at the start of the exam paper, it says that x equals minus b plus or minus the square root of b squared minus 4ac all over 2a is the quadratic formula. So our a equals 1, the number in front of x squared, our b equals minus 6, and our c equals minus 81. X equals minus 6, which is a minus and a minus there, plus or minus the square root of minus 6 squared minus 4 times 1 times minus 81 all over 2 times 1. So watching out for minuses. Minus 6 is positive 6, plus or minus the square root of 6 times 6 is 36, minus times a minus is a plus. 4 times 81, well, you might need to do that sum at the side, but if you have to, just do this. 4 ones is 4, 4 eights is 32. So that, and it's a minus times a minus, so it's a plus. So it's plus 324. 2 times 1 is 2. We have to get it down to d plus or minus d root e. So x equals 6 plus or minus the square root of 324 plus 36. So that's 324, 330, 360 over 2. Well, 360 is like a surd, yeah? You may not know if it's an exact square root, but we can work it out as a surd because we can do root 360. Two numbers at times together to make that, well, 36 and 10. So that means you get root 36 is 6, root 10. Now, root 10 can't be simplified further, so I can change my root 360 to 6 root 10. So x equals plus or minus 6, plus or minus the square root of 6, root 10 over 2. So that means that x equals, dividing the first thing by 2, I get 3, and the second thing by 2, I also get 3 root 10. And we're done there. SQA National 5 Maths 2021 Paper 1 Question 9 had express root 50 plus root 45 minus root 2 in its simplest form. So I'm having to simplify those surds and hopefully then add or take away some of them. So let's start off with root 50. Well, I need two numbers at times to make 50. 25 and 2, because 25 is a square number. That's 5 root 2. Same with root 45. I want two numbers at times to make 45. One's being a square number. Well, 9 fives is 45. So that's 3 root 5. So our sum becomes root 50 is 5 root 2. Plus root 45 is 3 root 5. Minus root 2. I can only add up the ones that are the same. 5 root 2 minus 1 root 2 is 4 root 2. So that gives me 4 root 2 plus 3 root 5. Don't be tempted to do anything else because you cannot add unlike such together. So I'm done there. Expand and simplify. So we've got root 10 times root 10. Well, that's just 10. We've got root 10 times root 2. Well, that's going to be root 20. 2 tens are 20. And we've still got plus 8 root 5. So at this point, we need to check if root 20 can be simplified as a surd. We're looking for two numbers that go into 20. One's a square number. Hopefully it'll be 5. Let's just check. Root 20 equals root. Well, 4 is a square number times 5. So that gives me 2 for square root and 4, root 5. So I can rewrite my problem as 10 minus 2 root 5 plus 8 root 5, which equals 10. 8 minus 2 is 6, so plus 6 root 5. And we're done. Can't add the 10 and the 6 root 5 because they're, well, different from each other. One's a whole number, one's got a root in it. Surds, SQA National 5 Maths 2015, paper 1, question 13. Express 4 over root 8 as a rational denominator in its simplest form. So I've got 4 over root 8. I can either simplify the root 8 at the start or at the end. I'll just do it at the end. So I'll just times by root 8 over root 8. That gives me 4 root 8 on the top over 8 on the bottom. I can immediately then see I can simplify the 4 and the 8 because I can divide by 4 and divide by 4 to get 1 root 8 over 2. And now I just need to check, is root 8 simplified? Well, root 8 is equal to root 4 times root 2, which is 2 root 2. So that means our answer here becomes 2 root 2 over 2. The 2's can be cancelled to 2 divided by 2 is 1, so that's just the square root of 2. 1 root 2 over 1, which is root 2. The next question says, a function f of x is defined as f of x is 2 over root x. Express f of 5 as a fraction with a rational denominator. So we're coming in with surds here, but we're still the same point for part 1 for 1 mark. All you have to write is f of 5 equals 2 over root 5. And then working that out with surds, times the top and bottom by root 5 to rationalise the denominator. We get 2 root 5 on the top over 5 on the bottom, and that is as simple as it's going to get. So we're okay. 2018 paper 1 question 11. Express 9 over root 6 with a rational denominator. So we start with 9 over root 6. We times by root 6 over root 6. So this gives me 9 root 6 on the top over just 6 on the bottom. I can simplify the number parts by dividing by 3. 3 goes into 9 3 times. 3 goes into 6 twice, leaving 3 root 6 on the top and 2 on the bottom for our final answer. SQA National 5 Maths 2019 paper 1 question 12. Express root 2 over root 40 as a fraction with a rational denominator and give it in its simplest form. So we've got root 2 over root 40. You can simplify now or after. So we'll simplify after. Root 40 over root 40. That gives me 2 times 40 is 80. So root 80 on the top. And root 40 times root 40 is just 40. So simplifying our root 80, we look for two numbers at times to make 81's a square number, the biggest you can find. 16 goes into it 5 times, so that is 4 root 5. So our final answer is 4 root 5 over 40. 4 goes into 40 10 times, so that's root 5 over 10, and we're done there. SQA National 5 Maths 2023 paper 1 question 8. Express 12 over root 15 with a rational denominator in its simplest form. So we've got 12 over root 15, I times by root 15 over root 15. So that gives me 12 root 15 on the top over 15 on the bottom. I can divide immediately by 3 goes into both of the numbers outside. 12 divided by 3 is 4 root 15. 15 divided by 3 is 5. Now I need to check if I can do the root 15. Root 15, is there any square numbers that go into that? Well, 4 doesn't go in, 9 doesn't go in, I mean 16 is too big, so can't be simplified, it's already simplified. And that means I've done a little check, my answer is done. This has been Clelland Math today. We've went through the whole of surds in National 5 Maths. We've went through simplifying surds, what is a surd, adding surds, taking away surds, times the surds, dividing surds, rationalising the denominator. Hopefully you found that useful and helpful. If so, give it a like and a little thumbs up. Maybe subscribe to the channel for weekly National 5 Maths videos. Take care, stay safe, and goodbye.